Welcome to another edition of Isaac Mathematics Online. Today we want to discuss how we can use law of change of base so as to solve logarithm questions whose bases are not the same. Now if you take a look at the question, the question on the board here, the base of this logarithm is 9, while the base of this is 3. So what do we need to do? We want to change this base 9 to base 3. So according to that principle, change of base, logarithm of y in base 9 is the same thing as logarithm of y in base 3, logarithm of y in base 3 all over logarithm of 9 in base 3. So this becomes 2 times logarithm of y in base 3 all over logarithm of 9 in base 3. Everything is raised to the power of 2 minus logarithm of y in base 3 is equal to 0. So from here we have base 3 at this side and also base 3 at the other side. So now this becomes 2 times logarithm of y in base 3 all over. We can easily simplify logarithm of 9 in base 3. How do we do that? Originally, logarithm of 9 in base 3 means what is the power to which 3 must be raised so as to get 9. So without wasting time, the power to which 3 must be raised so as to get 9 is equal to 2. So logarithm of 9 in base 3 can just be written as 2. And everything is raised to the power of 2 minus logarithm of y in base 3 is equal to 0. From here, these 2 can cancel the 2 up here. 2 here, 1, 2 here, 1. So this becomes logarithm of y in base 3 raised to power 2 minus logarithm of y in base 3 is equal to 0. So the next step now is to represent logarithm of y in base 3 by any letter you like. Because logarithm of y in base 3 is common to these two sides. So I want to use letter A to represent logarithm of y in base 3. So let logarithm of y in base 3 is equal to A. So if logarithm of y in base 3 is equal to 8 is equal to A, then A raised to power 2 minus A is equal to 0. So this is a form of quadratic equation. So we want to factorize this expression. What is the highest common factor of A squared and A? That is A. So you write A, open a bracket, A squared divided by A, that is equal to A, minus A divided by A, that is equal to 1, then is equal to 0. Now this means A is equal to 0 or A minus 1 is equal to 0. So it's either A is equal to 0 or A minus 1 is equal to 0. So if A minus 1 is equal to 0, then A is equal to 0 plus 1. A is equal to 1. But the unknown letter here is y, it is not A. Then we need to go back to this representation. Logarithm of y in base 3 is equal to A. So if A is equal to 1, then logarithm of y in base 3 is equal to 1. Then 3 raised to power 1 is equal to y. y is equal to 3. That is, the power to which 3 must be raised to get y is already 1. So y is 3. Also, if a is equal to 0, then logarithm of y in base 3 is equal to 0. Then, what is the power to which 3 must be raised to get y? So the power is already written here as 0. Then, 3 raised to power 0 is equal to y. And y is equal to, anything raised to power 0 is 1. So y is equal to 1. Therefore, y can either be 3 or 1. So this is how we can use the law of change of base to solve logarithmic equations. Thank you very much for your time and your attention. Please don't forget to subscribe to my YouTube channel, follow my Facebook page, like, comment and share. Thank you.